Hey guys, it's Miss Baker. Right now we're going over the lecture on page 223, how are ionic, covalent, and metallic bonds created. Okay, so to remind you, we have three different types of material on the periodic table. We've got metals, we've got nonmetals, and we've got metalloids. Now, hydrogen is a nonmetal, this one right here, okay? Let me color this for you. With crayon. So, the metals, or non-metals, sorry, I'm going to color in the non-metals red. So this is a non-metal, and these are all non-metals. Okay? The metalloids are blue. Okay, are dark blue. They're already marked on there. And then the metals, I'm going to make green for right now. I think that's green. Okay, so all of these are metals. Okay, now for our intentions purposes, the metalloids are going to be treated like nonmetals. Okay, so if it's metalloid, you treat it just like a nonmetal for right now. Right? So, okay. Nonmetals are colored in this one. Metals are colored here. And then you already saw the metalloids. Okay. So the next thing you've got to look at is a chemical formula. The chemical formula is a way a molecule is written telling you how many of each type of atom is in the molecule. All right, so here's the deal. When you're looking at the chemical formulas, you got to look. Every time you see a new capital letter, that is a new element. The subscripts, which are these little thingamabobbies here, those are telling you how many atoms there are of that element. So in these terms, there are 6 chlorines, you've got 9 hydrogens, and you've got 5 oxygens. Okay? In carbon dioxide, you see how it doesn't, in this one right here, see how it doesn't have a number right there? That means that there is, if it says its name, if it's got a capital letter there, you've got at least one of them. So you've got 1 carbon and 2 oxygens. Okay? In this one, Na is sodium. There's 1 sodium, 1 hydrogen, 1 chlorine, and 3 oxygens. Okay? Here is rust. You've got 2 irons, and you've got 3 oxygens. Okay, bonding notation. So, the upper right-hand corner equals the subscript charge or the oxidation charge. That is this right here. That's going to be a +1, +2, +3, plus or minus 4, -3, -2, -1. This has to do with how many electrons it's going to donate or it wants to steal, or how many extra electrons it has, or how many missing electrons. Okay, the bottom right-hand corner, that is the subscript number of the atoms of that element. So if this said 2, that would be 2 SYs. Okay, C4 means there are 4 carbons. The front symbol, the front number right there, that will tell you how many of that molecule there are. So if we had CH4 and we had a -2 and you had a 3 right here. So what this is saying is the CH4's overall charge is a -2. That means it has 2 missing electrons for it to be full, so it needs to steal 2 electrons. This 4 right here says that there are 4 hydrogens. There's no number right here, so that says that there is 1 carbon. And this says that this 3 is multiplying this whole thing right here. So this says that there are 3 CH4s. Okay? Just like that. Okay, a polyatomic compound are compounds that are bonded as a single unit and have only 1 oxidation charge for the whole unit. So ammonium, which is NH4. NH4 has a +1 charge. Remember, we don't write ones unless it's at 10 or 100 or 1,000 or 101, something like that. So NH4 means there's 1 nitrogen, there's 4 hydrogens. This entire thing is considered a single unit, just like if we had carbon. So if we had, let's say we had lithium or sodium, that's easier. Sodium has a +1 charge. NH4 has a +1 charge. This one is acetate. Acetate is C2H3O2, and it has a -1 charge. Chlorate is ClO, and it has a -3 charge. Nitrate is an NO3, and it has a -1 charge. Hydroxide is an OH, and it has a -1 charge. Carbonate is CO3, and it has a -2 charge. Sulfate is SO4, and it has a -2 charge. Phosphate has a PO4, and it has a -3 charge. When you are doing these on a test or on worksheets or anything, if you look on the back of your periodic table, you will find this list of all of these polyatomic compounds. Now, I know that list has very, very tiny charges. What you have to remember is the first one, the NH4 plus one, that is the only one that is a positive. All the rest of them are negatives. So that's fairly easy to remember. But remember, if you see a polyatomic, you have more than one capital letter, flip onto the back of your periodic table and you will find it there. All right, chemical bonds is an attempt to fill an electron shell. The entire goal is to fill the electron shells, to make them full. So an ionic bond is a metal plus a nonmetal. So if you've got anything on the left-hand side of the stair-step metalloids, with the exception of hydrogen, that's a metal. Plus anything on the metalloids or the non-metal side. So that is going to be an ionic bond. Okay, no, excuse me. That one is, it's got to be a metal and a nonmetal. A covalent bond is two nonmetals. You can also bond a metalloid and a nonmetal. The last one is a metallic bond. Metallic bonds are going to be any two metals bonded together. Okay, so you are going to have to, when we get into our work, you are going to have to use your periodic table to figure out if the material is a metal, a nonmetal, or a metalloid. Remember, ionic bonds is a metal plus a nonmetal. Covalents are two nonmetals or a nonmetal plus a metalloid. Or a metallic bond are two metals. Okay, so an ionic bond, you've got a metal cation. Remember, cation is an ion that is going to donate an electron, becoming positive. A nonmetal anion is an ion that wants to steal an electron and becoming a negative. So what happens is this metal is going to donate its electron. Remember, it's a +1 because it's got an extra electron. Chlorine is a -1 because it's missing an electron. So this electron is going to plug into that hole. This is going to be a positively charged ion. This is going to be a negatively charged ion. That is going to create a cation and an anion, and they will be oppositely charged, so they will attract each other. Okay, here's a nice little picture, and it says, boys, can you please explain what you are so attracted to over there? And the boys are the positives because they're donating electrons. The girls are negatives because they are taking electrons or stealing electrons. All right, this is another picture of it. These two are neutral. Look at their faces. They are not got any charge. They have the same number of protons as electrons. This guy has an extra electron, so he's going to give his electron to her. That takes him down to a noble gas. Its valence shell is full, and that fills this one's valence shell. This one is going to become a positive because it gave it away an electron. This one is going to become a negative because it stole an electron. And then they are going to become magnetically attracted to each other because they are going to have opposite charges. With an ionic bond, the net charges must add up to 0. If they don't add up to 0, you must add more atoms until it does. The numbers of each of the atoms are noted as a subscript. Now, if you're going to bond calcium and chlorine, you see calcium has a charge of +2, chlorine has a charge of -1. Calcium wants to give away 2 electrons. Chlorine only needs to steal 1 electron. So this calcium is going to give 1 electron to chlorine. That will make chlorine happy. But calcium will not be happy because calcium is still going to have an extra electron. So you're going to reach into your cup full of chlorine because you have unlimited amounts of calcium and chlorine. You're going to add another chlorine, and this is going to be a +2. This is going to be a -2. Now you've got 2 of these chlorines, so these 2 are going to go down into 0. Okay? Ba is a +2. O is a -2. +2 -2 equals 0 because that's the goal, is to make it 0. It becomes BaO. Potassium, K, is a +1. Sulfur, S, is a -2. So to make this a 0, you're going to have 2 potassiums. So K2S1. Okay? Fe, iron, it has a +3 charge. Br, bromine, has a -1 charge. You're going to have 3 bromines to equal out the 3 irons. So that is an FeBr3. Okay? All right. Okay. Ionic bonds is one big greedy thief dog. If there's an ionic bond, the electrons are the bones. All right? These normally have the same amount of bones, but when this dog gives away its bone to the other dog, the gray dog has 2 bones, the cream dog has no bone, so it's going to follow along to the other one until it can get that other bone away. Electrons are shown as arrows and are an easy way to visualize the electrons being given or accepted by the atoms. In these terms, magnesium has 2 arrows. Chlorine has a hole. So if this chlorine was fit into these arrows, you would have magnesium would have 1 arrow fulfilled by this hole, but it needs another one. So it would be MgCl2 because it would take 2 chlorines to fill in these 2 arrows. Okay? Here's another picture. A sodium electron is going to be donated to this chlorine atom. Okay, this one is going to have a +1 charge. This one will have a -1 charge. So this is going to be NaCl. Okay, a covalent bond is the bond by the sharing of 2 electrons. And these are 2 nonmetals, or this is a nonmetal and a metalloid. Okay, you see how they end up sharing the electron bonds here. All right, we don't care about non-polar covalent. Don't worry about that. Don't worry about that. Don't worry about that. Metallic bonds are bonds found in metals. They hold the metal atoms together very strongly. I want you to think of stepping stones in the water. The stepping stones are the nucleuses of the atoms. The electrons, when you have a metallic bond, the electrons just flow through the whole thing. They all share it. So the electrons are like the water flowing around the stepping stone nuclei. Okay, watch here. You see how the electron bones are just flowing around the dogs. Okay, watch the dogs. Electrons flow around them. Okay, so in this one, we're talking about compare and contrast these three things. So an ionic bond is a metal and a nonmetal. Covalent bonds are 2 nonmetals, or a metal and a metalloid. Metallic bonds are 2 metals. How they are all common is they all want to get their shells full. And they are either going to steal electrons, like in ionic bonds, or share electrons, like in a covalent and a metallic bond. And that is it for this